When it comes to trig, we're going to see that there are a few laws that have been proven throughout the course of history that will work to our advantage. One of these is the law of sines. So we'll get to what the law of sine is in just a moment, but for a little bit of review here, we need to figure out the lengths of sides D and E in this triangle here. So triangle DEF, we're told we have angles of 30, 60, 90, sides E, D, and 5. So what we can do is we can use our trig ratios here because we have a right triangle, and we can figure out just exactly what the sides of D and E are. And we can use our trig acronym SOHCAHTOA in order to figure out what these lengths are. So again, sine of our angle is equal to the opposite side over the hypotenuse. Cosine is equal to the adjacent side over the hypotenuse, and tangent of our angle is equal to the opposite over the adjacent side. So we can use any one of these three in order to figure out what our lengths are. So sides D and E, side 5, and first thing I see angle 30, length D is across from 30, and side 5 is adjacent to it. So we can use tangent. So tangent of our angle, which happens to be 30, is equal to our opposite side, D, over 5. So we're going to multiply both sides by 5. This will cancel out the 5s on the side with the fraction. So we're left with D equals, and then we have 5 times the tangent of 30, and we get 2.88675, etc. So I'll round up, just to be nice here, to be 2.9. So 2.9 for side D. Now what we have to do is figure out what side E is. So here we said side 5 was adjacent to angle 30, and side E is our hypotenuse. So here we have adjacent over hypotenuse, so 5 over E. Cosine of 30 is equal to 5 over E. And we'll multiply both sides by E in order to eliminate the fraction here. It will cancel out on the side of the fraction, and we have 5 equals E times the cosine of 30. And what we need to do is divide by cosine of 30. And this will cancel out on the side, leaving me with just E. And then we can divide 5 by the cosine of 30. And we get 5.77, so we'll round up to 5.8. So there are the two measures. Now in B, we are asked to find the lengths of X and Y. How is this different from part A? Well, if I take a look at the triangle from part A, notice we are given all three angles, 30, 60, 90 degrees. And we are told that it is also a right triangle here. We don't have that notation here, so we can't be really sure if we have a right angle. It's possible angle Z up there is 90 degrees, but we just don't know. So in that case, we can't use our trigonometry functions in order to figure it out. I mean, we could possibly end up with the correct numbers, but it would take a lot of work using other tricks of the trade rather than just sine, cosine, or tangent. So here what we're going to do is we're going to figure out what is sine of C, A, and B given these two triangles. So again, sine of C would be opposite over hypotenuse. So what they did was they gave us this height, gave us a little right angle down here. So we actually have two right triangles here once I drew the height here. So here we have this little right triangle, and then we have a slightly bigger right triangle. So sine of C would be opposite over the hypotenuse. Well, once I draw the height, the hypotenuse is now side A. So opposite of sine of angle C would be H. our height over side A. And sine of A is going to be the same thing, only opposite would be h, and the hypotenuse for that side would be c. So h over c. So there is the measures of sine angle C and sine of angle A. Now, this triangle down here, what is the sine of angle B? Well, again, we drew height with a right triangle, so we have a right triangle here, opposite over hypotenuse, so h over c. So h over c. So notice that it's all pretty much equal, h over c, and then we have a slight difference with angle C due to h over a. Now, the law of sine is basically a proportion. It relates the length of any two sides of a triangle to the sine of the angles opposite. So a over sine of A equals B over sine of B equals C over sine of C. So we can use that law of sine to create a proportion and figure out any one of the missing pieces. So again, we have three pieces here. If I'm dealing with the fractions dealing with A and B, as long as I have 3 out of the 4, I can figure out the missing piece. So what does that look like? Well, we have a surveyor here needing to determine the distance between 2 points, A and B. So there's our missing piece, A to B, that lies on the opposite bank of a river. We have a given point C that is 160 meters from point A on the same river as A. Measures of angle BAC and ACB are 41 and 55. Approximate the distance from A to B. So this is our unknown. We need to figure out just how far A to B is. There's our unknown. Now, what we do know is A to C is 160 degrees, and we have these two angles. Now, we also have a triangle here. In a triangle, the angle measurements will always add to 180 degrees. So all I have to do is add 41, 55 in my missing piece, and I know I have 180 degrees. So that's our first step. What is our missing angle? So all we have to do is subtract 41 and 55 from 180 degrees. And we get angle of 84 degrees. So now I see I have an angle and its respective length across from it, so opposite. And here we have angle C and an unknown. So in this case, we can use the law of sine to figure out what our missing side is. So in this case, we have sides A is across from A, side B is across from B, and side C is across from angle C. So here what we're going to have is side B over the sine of angle B equals side C over sine of C. Side B, we are told, is 160 degrees, and we just figured out that B, the angle B, is 84 degrees. So we have 160 over the sine of 84 equals side C, which is our unknown x, over the sine of angle C, which is sine of 55. Now with any proportion, what we want to do is we want to cross multiply. So cross multiply x times the sine of 84, and we're going to cross multiply 160 times the sine of 55. So we end up with 160 times the sine of 55 equals x times the sine of 84. So what we need to do now is to get x by its lonesome. So anytime we're multiplying things, we need to divide. So we're going to divide by the sine of 84. So what that will cancel out the sine of 84. And then with our calculator, what we want to do is we have 160 times the sine of 55. And I have two open parentheses, so I need two close parentheses. And I'm going to divide by the sine of 84. And to the nearest meter, we have 131.7, so we'll round up to 132. So 132 meters is x. Now for number 2, we have triangle ABC. We are told angle A is 30, A is 12, B is 10. We need to figure out angle B and include a diagram. So basically they're telling us draw a picture and figure out the angle that we're missing here. So we have triangle ABC. So angle A is 30 degrees. Side A is 12. And side B is 10. We need to figure out what angle B is. So there's our unknown. So we have the appropriate measures. We have angles and the sides across from it. So we can use the law of sine. And again, in this case, side A over the sine of A is equal to side B over the sine of angle B. So side A, we said, was 12 over the sine of our angle A, 30. And that is going to be equal to side B, which is 10, over the sine of angle B, which is x. So again, proportion means we cross multiply. So we have 10 times the sine of 30 equals 12 times the sine of x. Now because x is with the sine, we are actually going to divide by 12 here. So what happens is the 12s will cancel out, so we have the sine of x is equal to, and then we just have to do 10 times the sine of 30 divided by 12. So we get 0.416666667. So 0.41666 repeating. On and on and on and on. So because we're dealing with the sine of x, we actually have to figure out what the angle is. So this is where the arc sine comes into play. Now we can plug in arc sine of our answer or arc sine of 10 sine 30 divided by 12. I'll just do arc sine of the answer. So x is arc sine of our previous answer, 0.4166666, on and on repeating. So in our case, arc sine, and then if anytime you want to do something to the answer, instead of just doing 0.4166666, all you have to do is second answer. And it will do it to the function. So 24.62431.835. So we're just going to round up to 25 degrees. Now let's say we have this double triangle problem going on here. We got a car moving forwards at a tunnel carved out from the base of a hill. They gave us a nice diagram to show it. At the top of the hill is point H, and it cites two locations, points A, point B. It tells us the distance between A and B is 250 degrees, or 250 feet. And we need to figure out what the height is. So we need to use our law of sine here to figure out what it is. So we know, based on this, that from A to B is 250, this angle is 30, that's 45. So what we need to do is we need to essentially figure out our missing pieces here. So it's easier to find our missing angles here. We know we have a right triangle here, so we have a right triangle down there. That's 45, which means this here is 45 degrees. Now we know H is the unknown. And we also know that the big picture here, 30, 90, meaning the larger angle up top is going to be 60. So the larger angle is 60, the other angle for side H is 40, which means the other piece here is going to be 15 degrees. So there is our pieces here that we can use. Now, what we do know is we can use the law of sine to figure out missing pieces. So for triangle ABH, here we have angle 15 and the side across from it. Here we have angle 30 and we can figure out the length of H to be. We could also possibly use 90 and our hypotenuse, but we will use 30 and 15. So again, here we have our side, 250, over the sine of our angle that we have, 15, and that is equal to our unknown side here, H, to be over the angle that we were told, sine of 30. So we cross multiply, we end up with 250 times the sine of 30 equals x times the sine of 15. So we'll divide by the sine of 15 on both sides. So we get x equals, so we have 250 sine of 30 divided by sine of 15. And we get 483 once we round. So we have 483 feet for lengths B to H. So now we have our one of the missing pieces, and now hopefully possibly we can figure out what H is. And again, we can use the law of sine for anything. So notice here we have the right angle, 483 feet. So we have angle and opposite side. Here we have angle and opposite side of H. So we can figure out what the height is. So law of sine states H over the sine of 45 is going to be equal to 483 over the sine of 90. We'll cross multiply, so we'll end up with H sine 90 equals 483 times the sine of 45. Once again, we'll divide by the sine of 90. That will cancel things out on this side, so we're left with H. And then we will do the appropriate math, 483 times the sine of 45 divided by sine of 90. Then we get 341.5. And it does make sense, 341.5 feet. And again, it makes sense because it is smaller than the hypotenuse that we found in the previous step, 483. It is, the right angle should always have the hypotenuse across from it. So 483 greater than 341.5. Therefore, it does make sense. To the nearest foot, we would round up to 342 feet. Now let's say we're given a triangle here with not so nice measurements. We need to calculate the angle, measure of angle B to the nearest tenth of a degree, and use the law of sines to find the lengths of A to C and B to C to the nearest tenth, and then calculate the area to the nearest square unit. So what we need here is basically to do a little bit of math. Now 57.2, 78.4, that's 2 out of the 3, meaning all I have to do is subtract them from 180 degrees to get the third. So 180 minus 78.4 minus 57.2. means our third angle is going to be 44.4 degrees. So we're going to use the law of sine to find our missing angle. So right now we have angle C and the side opposite, so that's going to be one of our ratios. And then it really doesn't matter which of the other two we use to find B or C first. B comes first in the alphabet, or rather A comes first in the alphabet, so let's find side A first. So here we have A over the sine of A, which in our case is 57.2, equals side C, which we said was 14, over the sine of 78.4. We're going to cross multiply, so we get A sine 78.4 is equal to 14 times the sine of 57.2. We'll divide by 78.4, or sine of 78.4. So it leaves us with A equals, and then 14 sine 57.2 divided by the sine of 78.4 gives us 12. So side A is equal to 12, which makes sense because smaller angle, so the side should be a little bit smaller than side C. And now we can use either one to figure out what side B is. So again, we're going to use the law of sine to figure out what side B is. So might as well use C again. So we have side B over the sine of 44.4 equals side C, 14 over the sine of 78.4. Cross multiply to get B sine 78.4 equals 14 times the sine of 44.4. Just like in the previous problem, we'll divide by the sine attached to our missing letter, so sine of 78.4. That will cancel out, leaving me with just B. And then we'll do 14 times the sine of 44.4 divided by the sine of 78.4. So we get 9.999, well, and we'll round it to make it equal to 10. So side B equals 10. So we have sides 10, 12, and 14 in our case. Now what we have to do is figure out the area of the triangle. So area again is 1/2 AB sine C if we don't have a true right triangle. So and again, it doesn't matter which two sides we use as long as we use the angle that's included in the two of them. So everything's been related to angle C, so we'll use 10 and 12. So 1/2 times 10 times 12 times the sine of 78.4, which when we calculate it, times 10 times 12 times the sine of 78.4 gives us an answer of 58.77, and that is using law of sines to find missing sides and then using the area of a triangle sine wise in order to figure out the area.